Solutions that we'll do in section 4.2 are a little bit different. I've got a lot of stuff already posted on the website, so if you're not using that, remember to check that out. One thing I was going to show you here is I've got a little illustration, animation in Desmos about complements and supplements. I've got some other things that are going to come up throughout the chapter if you want to check those out. You're welcome to go in here, and they're all set up where you can play around with them, and they're interactive. I tried to make this one interactive where everything's kind of labeled for you. The control is just the angle we're going to look at. And down later, we're going to see a slider where you can actually change the angle. And actually, I'll go ahead and I'll slide down to that. So it says angle T in degrees. T because it's easier to think in time and radians. So anyway, but if you change the angle here, it goes from 0 to 90. I could have made it do more, but for the illustration here, it works better to be in the first quadrant. So the angle is this. This is the angle I'm referring to. So really small, up to 90. There you go. So let's put it pretty close to 45 to start. And then we'll start with a simple complement. I'll put this here, complement any angle, click the bubble to activate. So it's hopefully pretty straightforward. So the complement to a 45-degree angle is also 45 degrees. They have to add up to 90 total. Some things I want you to start thinking about. Let's try 30. So if T is 30, all right, well, 30 plus 60 adds to 90, so the other one, the complement, has to be 60. There's a reason the sine of 30 is the same as cosine of 60, and cosine of 30 is the same as sine of 60. If you look at how it's arranged, it's the same triangle, just kind of turned differently. So the sine is the y value, whereas cosine is the x. Well, if you do the complement, you're just basically changing the x and the y, so sine becomes the cosine, and so on. So hopefully it's not too confusing, but there's a reason that they're kind of interchangeable, and you do see that pattern, because when you take the sine value, say, of an angle, let's change the angle so it's something new. So if you found the sine value here, that would be the exact same thing as the cosine value of the complement, because it's the same angle, it's the same triangle, it's just turned differently. So this y becomes this x, this y becomes that x. So that's a identity you'll see from time to time. At this point, I've turned off the complement. I've scrolled down to supplement, and again, it says click the bubble to activate. I also returned that to a 45-degree angle. So if the original angle is 45, the supplement has to be whatever adds to that to make 180. So from here to there is 135 more degrees. And if you kind of think about this, and this is what I'm going to do on the homework problem I'm going to show. If this is the angle, and this is a supplement, just sort of rotate that back around, and that shows you where that 135-degree angle would land if it started at the origin. And as I play around with the angle, the thing to notice is, let's start with the y values. Right? So just pay attention to the height of the triangles. Well, wherever I go, the heights seem to be staying the same. And that's true. That's something that's definitely going to happen. So if you have a sine value of something here, and you take its supplement, then you're going to see the exact same sine value of the supplement. So here's a more concrete example just to think about that. So sine of 20, I'm saying that sine of 20 is equal to the sine of 160. So if I put that on my graph here, here's a 20-degree angle, here's its supplement, which is 160 degrees. The height right there is the exact same thing as the height right there. So those sine values are equal. And then if you look at cosine, look at how the lengths in the x direction are going to change. So as the angle's changing, the x lengths or x values, they're going to stay absolute value-wise the same length, but one angle is always going to be positive, one's going to be negative with the supplements. So this will become a rule too. If you've got an angle here and you know its cosine value, then the cosine of the supplement would be the opposite value. Here's a statement that I'm going to say is true based on that logic. Cosine of 30 is equal to the negative cosine of 150. And these are things on the unit circle, so we should be able to get these pretty easily. All right, so you ought to be able to get it without thinking a whole lot. The cosine of 30, that should be square root of 3 over 2. And cosine of 150, all right, well, that's like a 30-degree angle over here, so negative square root of 3 over 2. because the axis is going to be negative in that direction. And if you work out your negative signs, that is a true statement. So again, the point is, if you have two supplementary angles and you take their cosine values, one of them is going to be the opposite of the original. So cosine of 30 is positive, cosine of 150 is negative. So for example, if I said the cosine of an angle is 1/3, then the cosine of the supplement, which would be pi minus your angle, would have to be negative 1/3. So that's the idea. And I didn't mention it earlier, but I did add in a piece right here about the complements. So if you have sine of 15, it's equal to the cosine of 75. They're kind of interchangeable. The sine of one's the cosine of the other. So now I've talked about those points. Let's look at number 51. 49 comes up quite a bit also, but I've already included in the notes on the homework solutions page, so check that out. So let's say sine of t is 4/5. So I've got some stuff going on here, but most of it's going to come later. I do have an angle drawn where the sine value would be 4/5. That's really all I need to answer this question. So this is a complement, pi minus t. So if that's t, whatever makes it the rest of the way over, that's going to be the supplement. I said complement earlier, I meant supplement. So check out, I'm going to try to animate this, it's screwed, but hopefully get the job done. If you rotated this angle, the supplementary angle, over, so it started at the positive x-axis, then let's think about where that would land. So let's think about where that would land, over here. So if you started from the positive x-axis and went over, and the line doesn't turn out perfect, but that would have, the y value, the height, is going to be the same thing. So if the sine of this angle is 4/5, and you looked at the supplement, it is also going to be 4/5. It's going to be the same thing. This one is sine of pi plus t. So if you started already at pi radians and went t more than that, so that basically just puts you at the exact opposite place from here. So what that's going to do, that's going to give us the exact opposite y value. So if it was this high here, it's going to be that same height, but just negative, flipped around. So that's going to be negative 4/5. Because if you look at if you start putting sides in, same radius or hypotenuse, and this side's negative 4 now because it's going downward.